The sound begins not with a voice, but with the rhythmic, agonizing screech of a rusted iron gate swinging in the wind against a salt-crusted brick wall. It is the sound of Deptford, South London, where the Thames laps against the rotted wooden pilings of forgotten wharfs. We see a close-up of a tarnished brass plaque half buried in ivy, bearing a name that should be as famous as Edison or Tesla, but is instead a ghost: Sebastian Ziani de Ferranti. The camera pans up to reveal a landscape of luxury glass-fronted apartments and creative hubs, the sleek, sterilized face of 21st century gentrification. But beneath these foundations, in the mud of the riverbank, lie the massive, barnacle-encrusted cast-iron pipes that once carried the lifeblood of a revolution. This was the site of the Deptford power station, the Deptford Monster. In 1889, this was the most dangerous, most ambitious and most mocked piece of engineering on the planet. Today it is a silent stretch of the Thames path where joggers pass by, oblivious that the very concept of the modern electrical grid was born here in a hail of sparks and the smell of ozone. The irony is suffocating. The man who figured out how to light the world is himself left in the dark. The spark in the gallery. Our story begins not in a laboratory, but in an art gallery. It is 1887. The Grosvenor Gallery in New Bond Street is the height of Victorian aestheticism, a place for Oscar Wilde and the pre-Raphaelites. But in the basement, something far less refined is happening. The air is thick with the scent of hot oil and scorched silk insulation. Sebastian Ziani de Ferranti, a young man of just 24 with a sharp, hawk-like profile and an obsessive intensity in his eyes, is troubleshooting a failing electrical system. At this time, electricity is a luxury for the ultra-wealthy, delivered by small, sputtering DC generators that can barely push power more than a mile. London's sky is a chaotic web of overhead wires, swaying dangerously in the wind, installed by dozens of competing companies with no standards and no safety regulations. Ferranti looks at the flickering carbon filament lamps and realizes the fundamental flaw that his peers, including Thomas Edison, refuse to acknowledge. You cannot power a city by building a generator on every street corner. You need a cathedral of power. You need high voltage. You need alternating current. The visionary pedigree. Sebastian wasn't a common laborer. He was the son of a talented photographer and a concert pianist, a blend of technical precision and artistic scale. By the age of 13, he was already designing a magnetic machine at St. Augustine's College. By 16, he had patented a revolutionary alternator that was far more efficient than anything produced by the established giants of the era. The Grosvenor Crisis. The Grosvenor Gallery's lighting system was a disaster, a fire hazard waiting to happen. Ferranti was brought in as a consultant, and within months he had completely re-engineered the plant. He didn't just fix it, he turned it into a hub that began supplying power to surrounding shops and homes, creating the world's first central station model. The overhead war. To reach his customers, Ferranti ran 2,500-volt AC lines across the rooftops of London. This was unheard of. The deadly current scares were at their peak, fueled by Edison's propaganda machine. Every time a wire snapped or a horse was spooked by a blue flash in the rain, the press screamed for Ferranti's head. The London Electric Supply Corporation, LESCO. In 1887, backed by the wealthy Lord Lindsay and a group of daring investors, Ferranti formed LESCO. They didn't want to just light a gallery, they wanted to light the entire West End. But the authorities were closing in. The Board of Trade, led by the conservative Sir Courtney Boyle, viewed Ferranti as a dangerous radical. They demanded he move his monstrous generators out of the city centre. The Deptford Gamble. Ferranti's response was a move that many called industrial suicide. He chose an 8-acre plot of swampy land at Deptford, 7 miles away from the consumers. His plan? To generate electricity at a staggering 10,000 volts, a level of tension that had never been controlled in human history, and transmit it through underground cables into the heart of London. The aesthetic of the monster. The construction of Deptford was a Victorian Gothic nightmare. It was a cathedral of brick and iron, with chimneys that pierced the smog and massive 1,500 horsepower engines. The scale was terrifying. While other stations were measured in hundreds of lamps, Deptford was designed to power 2 million. The atmosphere of 1880s London was one of transition. The gaslight era was screaming its last, and the white magic of electricity was seen as something semi-occult. People expected the Deptford station to explode, to poison the river, or to strike dead anyone who walked above its buried cables. Ferranti, however, was not a man of superstitions. He was a man of the slide rule and the forge. As the massive steam pistons began to move, lubricated by the sweat of hundreds of stokers, Ferranti stood at the center of the storm, a young man betting the entire future of British industry on a mathematical certainty that no one else believed in. He was about to prove that distance could be conquered, but in doing so, he would make enemies of the very institutions that should have celebrated him.
The architecture of high tension.
The camera zooms into a cross-section of what looks like a primitive artifact, two concentric copper tubes separated by a thick, dark, waxy substance. This is the Ferranti main, and in 1888 it was the most controversial piece of hardware in London. While the rest of the world was trying to insulate wires with gutta percha or silk, materials that would melt or ignite under high pressure, Ferranti turned to an absurdity: brown paper. We see a montage of workmen in the Deptford workshop dipping miles of common brown paper into a boiling vat of ozokerite, a natural mineral wax. They wrapped this sticky, saturated paper around the inner copper tube, then slid it into an outer tube. It was a 20-foot-long, rigid pipe. No one believed it would work. Critics called it a fire stick, yet it was the world's first true high-voltage coaxial cable, capable of carrying the unprecedented 10,000 volts that Ferranti demanded. The Deptford Forge. The concentric secret. The physics were elegant. By using two tubes, one inside the other, Ferranti created a self-shielding system. If a workman accidentally struck the cable with a pickaxe, the outer tube, which was grounded, would immediately short-circuit the inner live tube, tripping the safety breakers at the plant before the man could be electrocuted. This was safety by design, decades before the term existed. The 1250 horsepower behemoths. In the heart of the Monster station stood the first two primary generators. These weren't the suitcase-sized dynamos used by Edison. These were massive, custom-built Ferranti Hick-Hargreaves steam engines. Each stood over 20 feet tall, with flywheels weighing dozens of tons. Ferranti designed the alternators himself because no manufacturer on Earth would guarantee a machine at 10,000 volts. He was his own supplier, his own engineer, and his own risk manager. The logistics of a ghost grid. To get the power from Deptford to the West End, Ferranti had to lay 28 miles of these rigid 20-foot pipes. Because they weren't flexible, every corner of every London street required a custom-forged joint. The cost was astronomical. Lesko was burning through its £500,000 initial capital at a rate that terrified the board of directors. The Board of Trade Inquiry 1889. The War of the Currents wasn't just a technical battle, it was a legal one. Sir Courtenay Boyle and the engineering elite held a massive inquiry to decide if AC was too dangerous for the public. Ferranti's competitors, like the Metropolitan Electric Supply Company, argued for smaller, safe 1000-volt systems. Ferranti stood alone, arguing that efficiency required scale. He was the only one who realized that 10,000 volts was the only way to minimize line loss, the energy wasted as heat during transmission. At a time when a skilled laborer earned perhaps £80 a year, a single Ferranti transformer cost hundreds. Every component was a prototype. There were no textbooks for this. Ferranti was writing them in real time. He moved his family into a house near the station, living and breathing the soot and the vibration of the turbines. Inside the control room, the switches were giant wooden levers 6 feet long, operated by men wearing thick rubber boots and standing on glass platforms. When a circuit was broken under full load, an arc of blue flame would leap 10 feet into the air, accompanied by a sound like a lightning strike. It was a workspace that required the nerves of a bomb disposal technician. The most cinematic moment of this struggle occurred when the Board of Trade inspectors arrived at the Deptford station, skeptical and fearful of the 10,000-volt death current. They believed the cables were a ticking time bomb buried under the feet of Londoners. To prove his design, Ferranti staged a demonstration that would be considered an ocean nightmare today. He instructed his assistant Harold Cole to take a cold chisel and a heavy sledgehammer. A live Ferranti main was laid across the floor, humming with 10,000 volts, enough power to instantly vaporize a human being.
Ferranti told Cole to cut the cable in half while it was energized.
As the inspectors huddled back in terror, Cole, holding the chisel with his bare hands, delivered a massive blow. The chisel bit through the outer tube and hit the inner core. There was a blinding flash, a roar like a cannon shot, and the safety fuses at the generator blew instantly. Cole stood there, perfectly unharmed, smiling at the inspectors. The grounded outer tube had done its job. The demonstration worked. The Board of Trade was silenced, but the victory was bittersweet. The scale of Deptford was so massive that it began to swallow the company. Ferranti had planned for 4 even larger generators, monsters of 10,000 horsepower each, with flywheels 46 feet in diameter. To put that in perspective, the Titanic's engines 20 years later would only be roughly twice that power. Ferranti was trying to build the 20th century in the middle of the 19th, and the friction between his vision and the reality of Victorian finance was about to reach a breaking point. The Deptford Monster was alive, but it was hungry, and it was about to face its greatest test: a winter that would freeze the Thames and a fire that would threaten to erase everything. The Golden Glow and the November Flare. The year is 1890. If you stood on the rooftops of Piccadilly Circus at dusk, you would witness a miracle.
One by one, the heavy, flickering gas lamps were being eclipsed by the steady, piercing brilliance of Ferranti's AC light. The Alhambra Theatre, the grandest playhouses of the West End, and the elite gentlemen's clubs of Pall Mall were no longer drawing breath from the local choking air. They were breathing the lightning generated 7 miles away in the salt mists of Deptford. This was the peak. For a brief window, Sebastian Ziani de Ferranti was the undisputed king of the New World. He had done what the experts at the Royal Society said was mathematically impossible. He had sent 10,000 volts through the mud of London and brought it out the other side as usable light. At this height, LESCO, London Electric Supply Corporation, was the talk of the London Stock Exchange. Shares were trading at a premium. The company had spent nearly £800,000, an astronomical sum in 1890, equivalent to over £100 million today, to build the Deptford infrastructure. Ferranti himself was a celebrity, the boy wonder of the electrical age. He was earning a salary of £2,000 a year plus royalties on his patents, making him one of the highest paid engineers in the British Empire. Legend tells of a dinner where Ferranti was asked by a skeptical aristocrat what would happen if a man touched the 10,000-volt main.
Ferranti, with his characteristic dry wit, replied, he would be translated into a better world so quickly he wouldn't even have time to say goodbye to this one. It was this blend of lethal power and absolute confidence that defined the era. The night the light died, November 15, 1890. The catastrophe didn't happen at the massive Deptford station, but at the old Grosvenor Gallery substation. A transformer, stressed by the massive loads of a London winter, caught fire. The silk and oil insulation turned into a Roman candle. The fire spread rapidly through the wooden floorboards. In an era before automatic circuit breakers, the only way to stop the fire was to cut the power from Deptford. For the first time, the monster went silent. The 3-month darkness. The damage was catastrophic. Because Ferranti's system was so centralized, his greatest strength, it was also his greatest weakness. When the Grosvenor hub burned, the entire West End went black. For 3 months, LESCO's customers were forced to go back to gas and candles. The prestige of the Deptford Monster evaporated overnight. The press, which had lauded Ferranti as a wizard, now labeled him a dangerous amateur. The boardroom coup. The directors of LESCO, led by James Stats Forbes, a man who understood railway balance sheets but loathed technical risk, had seen enough.
They viewed Ferranti's vision of 10,000 horsepower generators as monstrous megalomania. While Ferranti was in the workshops designing the massive flywheels that would have been the largest moving parts on Earth, Forbes was in the boardroom, plotting his removal. The cancellation of the giants. In 1891, the order for the 2 massive 10,000 horsepower engines was abruptly cancelled. The half-finished cast iron frames, weighing hundreds of tons,
were left to rust in the Deptford yard. Forbes demanded that the company focus on smaller, safer, and cheaper tech. He wanted a utility company. Ferranti wanted a revolution. The friction of time. There is a haunting parallel between 1891 and the modern tech landscape. Ferranti was suffering from the pioneer's curse. He had solved the engineering problems, but he had failed to manage the human friction, the fear of investors, the inertia of regulators, and the jealousy of competitors. We see a recreate of the final meeting. Ferranti, still only 27, stands before a group of grey-bearded Victorian financiers. He shows them drawings of a future where every home in Britain is connected to a single high-voltage spine. They look at him like he's speaking a dead language. They didn't want a national grid, they wanted a 5% dividend. "You are 20 years ahead of your time, Mr. Ferranti," Forbes reportedly said. "Then it is the time that is wrong, not the machine," Ferranti replied. In August 1891, Sebastian Ziani de Ferranti resigned from the company he had built. He walked out of the Deptford Monster, leaving behind his patents, his giant engines, and his dream of a totally electrified London. He was technically a failure, a man who had burned through a fortune to prove a point. But as he walked away from the Thames, the coaxial cables he had designed remained buried in the dirt, still humming with the 10,000 volts that would eventually become the standard for the entire world. The industry was moving on, but it was moving on over the very foundations he had laid, even as it tried to erase his name from the ledger. The exile to the north. Sebastian Ziani de Ferranti did not fade into a quiet retirement after the boardroom coup at Deptford. Instead, he took his brilliance north to the industrial heartland of Manchester. In 1896, he established a new factory in Hollingwood, founding Ferranti Limited. It was here that he shifted from being a disruptor to being the architect of the electrical age. While London struggled with a fragmented, chaotic mass of dozens of small power companies, exactly the scenario Ferranti had warned against, his Manchester works began churning out the fundamental components of the modern world: electricity meters, massive transformers, and the heavy-duty switchgear required for a national infrastructure. The prophecy of 1910. In his presidential address to the Institution of Electrical Engineers in 1910, Ferranti made a statement that was laughed off as science fiction. He predicted that by the mid-20th century, Britain would be powered by a national grid of high-voltage lines, and that coal would no longer be burned in homes, but converted into electricity in massive remote stations to eliminate the deadly smog of the cities. He was describing the world we live in now, 60 years before it became a reality. The war effort. During the First World War, the Ferranti Works became a vital hub for the British war machine, pivoting to produce shells and fuses with the same obsessive precision Sebastian had applied to his coaxial cables. He was awarded the Order of Merit and elected a Fellow of the Royal Society, the very institution that had once doubted his mathematics. The death of a giant. Sebastian died in January 1930. He lived just long enough to see the first pylons of the British national grid being erected across the countryside. He saw his 10,000-volt madness become the standard operating procedure for the entire planet. But as the grid grew, the name of the man who conceived its DNA began to slip from the public consciousness, replaced by the brand names of the corporations that bought his patents. The concrete tomb of the monster. What happened to the Deptford Monster? The original station, Deptford East, was expanded and modernized, eventually joined by the even larger Deptford West in 1929. For nearly a century, this stretch of the Thames was the beating heart of London's power. It survived the Blitz, its chimneys standing like defiant fingers through the smoke of Nazi firebombing. But by the late 1960s, the era of coal-fired urban power was ending. The decommissioning. Deptford East was shut down in 1957 and Deptford West followed in 1983. The massive Hick-Hargreaves engines were broken up for scrap. The 46-foot flywheels that Ferranti had dreamed of, those symbols of Victorian industrial sublime, were fed into the blast furnaces of the very steel mills they once powered. The erasure. In the late 1980s, the chimneys were detonated, the brick cathedrals were leveled. The site sat as a toxic, oily wasteland for decades, a scar on the riverbank that no one wanted to touch. The gentrification of memory. Today, if you visit the site at Deptford, you will find the Deptford Project. It is a landscape of high-end apartments with names like the Wireless Factory or the Raw Power Lofts, a hollowed-out mimicry of the industry that once lived there. There is a Ferranti Close nearby, a small, unremarkable street that most residents assume is named after an Italian restaurant or a forgotten local councillor. The only true physical ghost of Ferranti's genius is hidden in plain sight. In the Science Museum in Kensington, a small 3-foot section of the original 1888 Ferranti main, the brown paper and copper pipe, sits in a glass case. It looks like a piece of primitive plumbing. It is, in fact, the blueprint for every high-voltage cable under every street in the world. The story of Sebastian Ziani de Ferranti is the ultimate paradox of the industrial age. We live in a world that is fundamentally Ferrantian. We take for granted the silent hum of the grid, the ability to send power across continents, and the safety of the insulated cables